Hello guys, we are back with our next lecture. In this lecture, let us go through the next topic, that is cryptography, guys. Okay, so basically this cryptography concept is not there in 2022 syllabus. I'm being clear with it, guys. So it's not specified in the syllabus. So mostly there will not be any questions from this particular topic, but there is a rare chance we could get a question. So as we have already learned this concept in 2020 syllabus, sorry, 2021 syllabus. So that is the reason why I want to cover it anyway. Okay. Yes, so let us discuss. So basically what exactly is cryptography, guys? So cryptography is nothing but assume that I want to send a message to my friend. Okay, so if I send that message in the internet, is it safe, guys? So someone can in between, someone can hack into that particular way which it is going and he can read the particular data, right? Yes, so to avoid these kind of issues, we do cryptography for our particular data. So basically what exactly is cryptography is, so assume that I want to send ABCD to my friend. Okay, so first of all this particular message will be encrypted. So it will be passed through an encryption algorithm and this encryption algorithm will convert this into a ciphertext. So what exactly ciphertext will does is, what exactly ciphertext is, it is nothing but an unreadable format of data. So I wanted to send ABCD, but if you observe here, so it is something else, right? Yes. So this data will be transferred in the medium. So assume that a hacker hacked into the system and he read this data. Can he understand anything? No, right? Yes. So that is the disadvantage here for that hacker, and it's an advantage for us. So and once it is received by the receiver, he will decrypt that particular message and he will get the original message. So this concept is nothing but cryptography. Now you got an idea, right? Yes. And it's an interesting process. You are getting the idea, right? Yes. Okay. So basically cryptography can be done in two different ways, guys. So the first method is a symmetric key cryptography and the second method is a asymmetric key cryptography. So in symmetrical key cryptography, what we do is we use the same key to encrypt the data as well as decrypt the data. So basically you will inform the receiver that you are using this key, so you also use the same key to unlock. So that is the concept of symmetric key. Okay, so now your question will be, so please give us an example, right? Yes. So assume that I am sending a bit number 1010. Okay, so what I will do is before sending this message, I will encrypt it. So what I will encrypt is I will make the complement of it, guys. So what is complement of this number? It is 0101. Okay, so what is my key here? It is nothing but complement, right? Yes. So I did complement it. Okay, so this will be sent in the network and if any hacker tries to hack it, he will get this data. He don't know that my key is complement, right? Yes. So once it is received at the receiver side, the receiver will decode it. So how he will decode it? He will use the same complement key. So he will again apply complement on this. So it is 1010. We got the same message. So this is the concept of symmetric key. You got the idea, right? Yes. So this is the concept of symmetric key, guys. Okay, so the next type of method is a asymmetric key. So basically for asymmetric key, I will give a small example, guys. Okay, so basically in asymmetric key, each and every device will have two different keys. So one is a private key and the other is public key. One is private key and one is public key. To be clear, if you are A, you know yours private key and your public key, but you know B's only public key because it is the only public key and private key is only for itself, guys, to be clear. It is some kind of secret key which you will never say to anyone. So that type of key is nothing but the private key. Got it? Yes. So for this, we will use these four keys to make the encryption, guys. But the only thing that we use two keys to make the encryption and two keys for decryption. Okay? Yes. So for easy understanding, let us take a small example, guys. Okay? So assume that if I send ABC, what I will do is, so on the sender side to encrypt this message, I will add +1 to each one of them. So if I add A +1, what is it, guys? So A +1, so what is after A? It is B. What is a B +1? It is a C. What is C +1? It is D. So this is what I will send in the network. Okay. So once it is received by the receiver, he will do -1. So here I did +1, here I did -1. So here both the keys are different, right? Yes. So instead of B, he will do -1. So I will get A. Instead of C, he will do -1. He will get B. He will get C. So he got the original message. So this is the concept of asymmetric key. Means here we are using different keys. Okay. Yes. So public keys are known to all and private keys are private to them. Got it? Yes. So now you are understanding, right? So how exactly it is working? Okay. Guys, this example is only with respect to asymmetric key, like how it works. It is not with respect to private and public key. Please understand it, guys. Because if you are using private key and public key, you should use two keys. at this point and 2 keys at decryption. Got it? Yes. So how we are going to use them, I'll be explaining you, so don't worry. Okay? Yes. So what is a confidentiality and what is authentication, guys? So these two terminology are really important when we are talking about asymmetric key or data transfer, guys. So what exactly is confidentiality is sending to correct person. Okay. So assume that I am sending my data to someone. Okay, so if I send it to wrong person, is it a good thing, guys? So assume that you wanted to say something to your friend and you told it to some other person. So that is an issue, right? Yes. So that is nothing but confidentiality. So what we do here is, so with the plain text, you will bind it up text with your friend's public key. Okay, so who can unlock this key is your friend's private key can only unlock it. So basically it is a type of lock which locks with one key and which unlocks with other key. So it's a bit different type of thing, but it's an interesting thing, right? Yes. So basically this public key will cancel off with only B's private key. If you try C's private key, it will not work. So that is the concept of confidentiality, guys. So with this understanding, you can clearly say that whoever can read the text, he is none other than B, right? Yes. So here we are successfully achieving the confidentiality. Similarly, authentication. So authentication is nothing but who is the sender. So if you are getting some data, it should be from the sender, right? So some hacker should not send it to you like your friend. So that is the thing, right? So for that we use the concept of authentication. So what we do is here is, so when you are sending your particular text, you will bind that particular text with your private key. Okay, and who can unlock this particular thing, guys? So this can be unlocked with A's public key only, right? Yes. So anyone can read it, but it will work only with A's public key, which means indirectly it was locked with A's private key. So with this understanding, you can clearly say that A is the sender, right? Yes. So this is the concept of authentication. So if you combine these both, that is the concept of asymmetric key, guys. So what we do here is, so A is having one private key and A is having one public key. B is having one private key and B is having one public key. If I want to send some particular data, first I will pack it with my private key, then I will pack it with my receiver's public key. So I will send this particular message in the network. So once this message has been received by our receiver, he will match his private key and he will cancel with this public key, and then he will match my public key with his private key and he will open the message and he will read it. So this is the concept of asymmetric key. Okay. So I hope everyone got 100% clarity about symmetric and asymmetric, right? Yes. I think now you can explain it to anyone, right? Yes. So this is an interesting concept, guys, to be clear. Okay. Yes. So basically on this concept of cryptography, there are two popular problems, guys. So the first question will be with respect to RSA algorithm and the second method is with respect to Diffie Heelman algorithm, guys. So these are the two popular algorithms, and to be clear, these algorithms, if you just remember the formulas, you can solve them, guys. So this computer networking subject is conceptually really interesting, but if you want to just solve the problems, I don't want to understand the concept, I just want to solve the problems. If you remember the formulas, you can blindly solve them, guys. There could be some silly mistakes with respect to theoretical questions, but numerical problems, you can solve them 100% clearly. Okay, yes. So now let us discuss about RSA algorithm. Okay, so in RSA algorithm, if you assume Bob is our sender, Alice is our receiver. Okay, so here Bob will have one private key and public key, right? Yes. Okay, so here we calculate n. N is nothing but p into q. So this multiplication is n, and we calculate phi n. That is nothing but p minus 1 into q minus n. Q minus 1. Okay, guys, I don't want one question, that is how we derive these formulas, guys, because these formulas we are not going to go in detail about derivation. So I think you have already studied about RSA algorithm in your theoretical classes, right? Like in your semester and all those things. So there will be some major flowchart. So if you derive that flowchart, you might get these formulas, guys. So from that only I think these formulas are derived. Okay, yes. Okay, so LIC will be having E and D as his public and private key. So if you multiply E into D and you mod it with this particular n, so write it n instead, sorry, phi n. Okay, so if you mod it with phi n, you should get 1. Okay, so they will give one thing, guys. So they will give private key or public key. So the other key we need to find. So that is the given question. Okay, and we have two more formulas. C is equals to PE mod n and P is equals to CD mod n. Okay, yes. So once let us go through the understanding of the example. So once we go through the example, you will get a clear idea, guys. Okay, yes. So in question, they clearly give the Bob P value as 7 and Q value as 11. So now what I will do, I will calculate N. It is nothing but multiplication of P and Q, right? Yes. So I got 77. Okay. So after that, I will calculate phi N. That is nothing but 7 minus 1 is 6 into 11 minus 1 is 10. So that is a 60. After that, I will calculate E into D mod phi n. So here in question, assume that they give the E value as 13. That is nothing but the public key. Okay. So I will calculate it and I got the value of D as 37. Okay. So what is this 37? It is nothing but my private key, right? Yes. So assume that my message which I want to send is 5. Okay, so C is nothing but the ciphertext, guys. So C is equals to P power E mod N. So P is nothing but our particular message which I want to send. So 5 power E. So what is the value of E? It is 13. So E power 13 mod 77. So we got 26. So this is the message which I send in the network. Okay, so this message once I send in the network, that is nothing but P is equals to the next formula, P equal to CD mod N. That is nothing but, so this will be applied on the receiver side, guys. So P equal to 26 power 37 mod 77. So we got 5. So that is what the sender has sent. So this is the logic of RSA algorithm. Like it's something like magic, right? So you apply some formula, you will get one result, and you apply some other formula on the same number, you get the original result. So that's something like magic. I'm really interested in these type of problems, guys. Okay, yes. So now you got an exact idea, right? So how exactly the formulas are working? Yes. Okay. So the second method which they ask is a Diffie Heelman algorithm, guys. Okay. So here also the concept is almost the same, but the formulas are a bit different, guys. Okay, yes. So here we will have P and X, similarly Q and Y. Okay, so we will calculate R1 and R2. So R1 is nothing but Q power X mod P. R2 is nothing but Q power Y mod P. So we will calculate them. Okay, and we will exchange these two things. So basically these two things are something like keys, guys. So if you recall, we discussed about key exchange, right? So we need to exchange those keys. Whenever we want to use same key or different key, we need to exchange those keys to unlock, right? Yes. So that is the reason why we exchange those keys. And if the value which we want to send is 19, so 19 power 6 mod 23 and 8 power 15 mod 23. So we got 2 as a result. So the original message which we want to send is 2. Got it? Yes. So it's a quite interesting method, guys. Right? Yes. So this is the concept of Diffie Heelman algorithm. So now at least, so let us keep the problems aside. At least you understood how exactly cryptography will work, and it's a bit interesting, guys, if you agree, right? Yes. So I hope everyone got a clear idea with respect to this cryptography concept. So in the next lecture, let us go through some basic terminology like repeater, hub, bridge, switch, router, and gateway. So that will be the last lecture with respect to my according, guys. So if there are any missing topics, I'll be covering them pretty soon. Okay? Yes. So in the next lecture, let us discuss these basic concepts. Okay? Yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.